His first thing we're going to do is find when I'm increasing, decreasing, and my local extreme values. So to find whether I'm increasing or decreasing, I'm going to find the first derivative, set it equal to 0, and solve for x. Those will be considered my critical points. My critical point also occurs when the derivative does not exist. So it's when the derivative does not exist or the derivative is equal to 0. So my first derivative is going to be 4x minus 4x cubed. So I'm going to set that equal to 0. I'm going to factor out of 4x. And I'm just going to factor it one more time. I'm going to have 1 minus x, 1 plus x. So I'm going to have 4x equals 0, 1 minus x equals 0, 1 plus x equals to 0. So x is equal to 0, x is equal to 1, and x is equal to negative 1. And there's not going to be any place where my derivative does not exist because I don't have a denominator. Only when I have a denominator do I have to worry where the derivative does not exist. So then I'm going to check, do a number line, so I'm going to check my derivative because my derivative is going to be the slope. So I'm going to see if my slopes are going up, increasing, or going down, decreasing. I'm going to check negative 1, 0, and 1. So I'm going to check to a number to the left of negative 1. So a number to the left of negative 1 would be negative 2. So I'm going to substitute negative 2 into my derivative. So 4 times negative 2 is the negative number. One minus negative 2 is positive. And 1 minus 1 plus negative 2 would be a negative. So a negative times a negative would make a positive. So a number between negative 1 and 0 would be 1/2 or negative 1/2. So I'm going to check negative 1/2. So 4 times negative 1/2 is negative. 1 minus negative 1/2 is positive. And 1 plus negative 1/2 is positive. So this is going to be a negative interval. So now I'm going to check number between 0 and 1. So I'm going to check 1/2. So 4 times 1/2 is positive. 1 minus 1/2 is negative. And 1 minus 1/2 is positive. And 1 plus 1/2 is also positive. So a number to the right of 1 is going to be 2. So I'm going to check 2. So 4 times 2 is positive. 1 minus 2 is negative. And 1 plus 2 is positive. Okay, so here's my number line. So I know that I'm going to be increasing, decreasing, increasing, decreasing. So that means negative 1 is where my max occurs, 0 is where my min occurs, and 1 is where my max occurs. So for part A, it asks when is it increasing? It is increasing in the intervals negative infinity to negative 1 and 0 to 1. Part B asks where is it decreasing? It is decreasing between negative 1 and 0 and 1 and infinity. Part E says the extreme values. The extreme values are actually the y values. So I know where they occur. So I'm going to substitute negative 1, 0, and 1 into the original equation. So when x is 1, and this is going to give me my y value. So this is going to be 17. So my max, I can write it as a coordinate. I can write it at 1, 17, or I can say my max is 17 and it occurs when x is equal to 1. When x is equal to 0, my y value is 16. So that is my min. So my min is 16 and it occurs when x equals to 0. And when x equals to 1, another local max is going to be 17. So I'm going to have two max at 117 and negative 117. And I'm going to have a minimum at 0, 16. Okay, so part C, D, and F asks to find the points of inflection. So to find the points of inflection, I'm going to find the second derivative. So my second derivative is going to be 4 minus 12x squared. So I'm using this right here. So it's going to be 4 minus 12x squared. I'm going to set that equal to 0. So 12x squared is equal to 4, or x squared is equal to 1/3, or x is equal to plus or minus the square root of 1/3. Okay, so those are possible points of inflection. So I need to check the sign of my second derivative to see if they're actually points of inflection. So since we're doing this without a calculator, and we don't know what 1 over the square root of 3 is, you kind of have to go back and go, okay, the square root of 1 over 3 is between the square root of 1/9 and the square root of 1/4. So that's going to be 1/3 and 1/2. So I know that 1/3 is the square root of 1/3 is between 1/3 and 1/2. So just kind of gives you an idea of where you're at. So I'm going to pick a number to the left of -1 square root of 3. So I'm going to pick -1. So if I substitute -1 here, I'm going to get 4 minus 12, which is a negative number. So a number between negative square root of 1/3 and positive square root of 1/3. So I'm going to check 0. So 4 minus 0 is positive. And I'm going to check 1. So 4 minus 12 is negative. So what that tells me is that my graph is concave down, concave up, concave down. So part C asks, where is it concave up? It's concave up between negative square root of 1/3 and square root of 1/3. Where is it concave down? From negative infinity to negative square root of 1/3, and from square root of 1/3 to infinity. And then what are your points of inflection? Well, I'm going to have 2 points of inflection. They're going to occur when square root of 1/3. And as we substitute that into the original equation to get the y value. So we're going to substitute 1/3 into the original equations to get what my y values are. So when we substitute that, we're going to get 149 over 9 for both points. So remember, if it asks what the inflection points are, you need to give the coordinate. If it just asks what are the x coordinates, you just need to give the x coordinate and not find the y value.